Alright guys, so today we're going to be covering 2.2 linear equations. My goal for the end of the day is for hopefully you to be able to identify linear equations and also write and graph linear equations in standard form. Now if you don't know what any of that is, do not worry about it. We're going to spend all day today trying to figure it out. So to start off with, do not worry about the entry task. That is the entry task that I gave you guys at the beginning of the class, so you should already have this on top of your paper. What I'm going to do is technically scroll down to start off from right here to start discussing what are linear equations. So, what does linear mean to you? How in the world are we going to recognize linear graphs? How are we going to recognize linear equations? Now the graphs, which is what we're going to start off, is super easy to know if it's linear. Because just like the name suggests, linear means a straight line. So if I ask you, hey, is this graph linear? If you have a straight line, if it looks like a straight line, then it is linear. That's literally what the definition means. If you have a linear graph, that means you have a graph that is a line. Now, of course, that line can face that way. The line can face something like this. It doesn't really matter as long as it's a straight line, you know that it's linear. Now, when you have something that's non-linear, it's not going to be a straight line. It could be something like this, and we're going to cover that a little bit later this year, but you can tell that that graph is not linear because it's not a straight line. So I think that's enough for graphs. It's really straightforward. Is it a straight line? Yes, that means you have a linear graph. If it's not a straight line, then that means that you do not have a linear graph. You just say non-linear or not linear. Now, equations could be a little bit tricky because it takes a little bit more thinking. Now, these are the suggestions I have. Memorize these. If you have an equation that follows these rules, then that means if you were to graph that equation, you are going to get a straight line. Your graph is going to look something like that, some type of straight line. Now, let's say that your equation follows one of these rules. Then that means that you're not going to have a straight line. So these two things go hand in hand. If you have them in one and you don't have them, then they're going to give you the respective graphs. So let's start going down each and every single one of these rules. In order to have a linear graph, that means you're going to have a graph that's a straight line. All variables need to have a degree of 1. Now, what happens if you have a variable that doesn't have a degree of 1? Then that means you're going to get something that is not a straight line, just like this example. In order to have an equation that's linear, your variables can only be multiplied by constants. So let's say a constant could be any number that I want, like 3. If you have something like 3x, that is absolutely okay. That's just a constant times the variable. If you follow these two rules, for the most part, you are going to get a graph that's a straight line. Now, if you have a variable that's multiplied by another variable, something like x times x, then that means it's not going to give you a straight line. Put that in your graphing calculator, and it's not going to get you a straight line. It's going to give you something else. Also, you can have something like x squared. Keep in mind that when you have something like x squared, you're multiplying something, or you're multiplying the x by itself twice. So that's just another example of how if you were to graph that, you will not have something that's a straight line. Also, keep in mind that you cannot divide by a variable. So you can't divide by a variable because it'll give you something that's called the reciprocal function. So we're going to use these two rules to help us figure out, and I'm going to erase this right here so that we have a clean slate. We're going to use these two recommendations to figure out if these 6 equations would give us a graph of a straight line. AKA, are they linear equations? Are they equations that give us linear graphs, straight lines? So let's analyze number 1. Notice I have f of x, which is just function notation, is equal to 10 minus 5x. Do all variables have a degree of 1? I'm looking at this here. I notice I have one variable of x. Its exponent is a 1. Since this exponent is of 1, that means that that variable has a degree of 1. That means that, okay, it checks off that. Are all variables multiplied by a constant only? Again, we only have to concentrate on that variable. Notice that the only thing multiplying is at -5. A -5 is just a number. It's a constant. That means if I were to graph this on a graphing calculator, if you were to graph it yourself, that means that, yes, you would have a linear graph. That is a linear equation. All right, so let's look on number 2. G of x is equal to x squared minus 4. I am asking you if this equation is a linear function. So let's go through our rules. Do all variables have a degree of 1? I'm looking at this variable here, and I notice it has a degree of 4. That automatically tells me that no, this is not a linear function. If you were to put that in your graphing calculator, you will not get a straight line. Now, when something is a linear equation, if I ask you the same problem on a test, all you have to do is tell me yes if it is. If it's no, you need to tell me why. And you would say no, because x has a degree of 4. And that's all I need. All right, very next one, notice that we have 3x, or for 3, we have h of x of y is equal to 2 times xy. Remember, you're just really worried about your equation here. Now, do all the variables have a degree of 1? Now, this x doesn't have an exponent, so it's a 1. This y also has a 1. Our variables can only be multiplied by constants. Now, notice that I have 2 times x times y. That means that a variable is getting multiplied by another variable. If you were to put this in your graphing calculator, it would not work. So I want you to say no. Variables are multiplying each other. There we go. All right, so the very next one, notice that these ones I tried my best to kind of trick you guys to make sure that you understand the definitions of what makes a linear equation and what doesn't. So looking at this first one, I like to go down the same line. I look at all my variables. Here's a variable, it has a 1. This variable here has a 1, or a degree of 1, is what I was trying to say. So that means that so far, this is a linear equation. Now looking at each of my variables, I notice what's getting multiplied. This one's getting multiplied by a 4 squared, and the other one's getting multiplied by a 3. 4 squared is just a number, it's 16. So that means that it is getting multiplied by a constant. So this is a linear equation. A lot of people will be like, okay, but I have an exponent of 2. And that means that the 4 has a degree of 2. But remember what I said here, your variables have to have a degree of 2. So, on to the next one. Notice we have pi times x. Is this a linear function? Is this a linear equation? And the answer would be yes. Notice you have one variable, it has an exponent of 1. Technically, you're multiplying by a letter, so to speak, or some type of symbol, which is pi, but pi is just a constant, so you're okay. The very next one, notice that we do not have a linear function. The main reason is because we are dividing by a variable. Whenever you divide by a variable, it's going to give you something that's called a reciprocal function. We'll learn about it a little bit later, probably a little more in pre-calculus, but you're going to get something like that, which is not linear. So that's pretty much the general idea of what makes a linear graph linear, what makes a linear equation linear. So that way you guys are able to recognize it and be able to start graphing. So this whole section, what we're doing is we're going to start graphing linear equations. And there are several strategies on figuring out how to graph linear equations. The very first one we're going to be learning is standard form. Now, standard form are linear equations that are written in the form ax plus by is equal to c. More importantly, what I want you to notice here is that your x and your y are on the same side and everything else is on the other side. Now, I'm going to give you guys a little more rules. Your a, b, and your c are integers whose greatest common factor is 1. So when you read that, you need to be saying, okay, I have an a b, and a c. There should not exist any number that could divide all 3 of those, a, b, and c, evenly. That's not 1. Your a has to be greater than or equal to 0. So that means that your x, your coefficient the x, always has to be positive. And of course, your a and b are both non-zero, because if they are 0, then they will start canceling out stuff. Now, that is a very kind of wordy definition, but you'll see that once we practice these in the order I like to do these, they become a lot easier. So I'm looking at number 1 here. Number 1 there is a linear equation. All your exponents have a degree of 1. So that means that it's a linear equation. Let's try to put it into standard form. What I like to do is I like to think of it as 2 sides of an equation. Right? I look at my 2 sides of an equation and I ask myself, are my a or are my x and my b on the same side of the equation? And the answer here would be no. Notice that your y is on one side and your x is on the other. Well, which one do I move where? Well, now the only stipulation you have in terms of where they go is that your a always has to be positive. That means the coefficient in front of your x has to be positive. It is negative right now, so I'm going to add 2x. So that way it becomes a positive. Notice I cannot combine 2x with y, so I'm just going to rewrite it over as 2x plus y is equal to the 3. Now, are my x and my y on the same side? On the same side, I would say yes. Is your a greater than or equal to 0, aka is it positive? And the answer is yes. Notice that it is positive there. Are your A and your B both non-zero? Yes, and that means that, one more rule, is there a number that I could divide 2, 1, and 3 evenly that's not 1? And the answer is no. So that means I have it in standard form. Your A would be 2, your B here would be 1, and then your C would be 3. Keep in mind that your A is always a coefficient in front of the x, so notice that my coefficient's a 2. Your B is always a coefficient in front of the y, which is a 1, and then of course your constant on the other side would be your 3. It's always going to be the same, your A, B, and your C. All right, so cool. Very next one, notice that I have a linear equation. Now I need to figure out how to get it in standard form. Now whenever there's fractions, keep in mind that you can never ever have fractions. They have to be integers, whole numbers. So how do we get rid of fractions? Well, it's very easy because all you have to do is multiply by the denominator. When you multiply by 5, notice that these 5's cancel out. You're left with a negative 3x is equal to 15y minus 10. Now that I have the fractions out of the way, I can see if I have my x and y on the same side. And the answer is I don't. They're on opposite sides. So I can see clearly here that I have to move one of them over. And now, is my a, the coefficient in front of the a, positive or negative? It is negative, so that means I'm going to move that over to make it positive. Notice I have nothing on the left side, so that is a 0. A 0 is going to be equal to 3x plus 15y minus 10. Now I do have my x and y on the same side, but notice that I do not have all my constants on the other side. So I'm going to add 10 to both sides. These cancel out. 10 is equal to 3x plus 15y. So now I can see here that my x and y are on the same side. I don't have any fractions, and I'm pretty much there. Now notice that on the prior problem, I had my x and y on the left side of the equation. Now this time I have it on the right side. That doesn't really matter. You can move it over if you want, but you won't be marked wrong for doing the left side or the right, or leaving your x and y on either side. All right, so let's do number 3 here. I'm going to draw a little line here so that way we can see it a little bit clearer and also change the colors. So I can see here automatically that I do not have my x and y on the same side. So let me write it here so that way I can have room to work. I do not have it on the same side. My x and y are not on the same. But I notice that in order to figure out what to move, my x, my coefficient in front of the x, that 8 is already positive. So I need to move the y over to keep that coefficient of the x positive. These cancel out. 0 is going to be equal to 8x minus 4y plus 10. Now that I have my x and y on the same side, all I got to do is minus 10 on both sides to get my constants on the other side. End up with negative 10 is equal to 8x minus 4y. Now remember that the greatest common factor of your A, your B, and your C has to be 1. That means there can exist a number that divides all of these numbers other than 1. There is no number that exists other than 1 that could divide all those. Now think about this. Is there a number that divides 10, 8, and 4 evenly that's not 1? And the answer is yes, 2 does. So negative 10 divided by 2 is a negative 5, which is equal to 8 divided by 2, which is 4x. And also, negative 4 divided by 2 is a negative 2. Don't forget my y. Now, sometimes I'm going to ask you for your A, B, and your C. Sometimes I'm not. So keep in mind here that I am, just to show you a different example. Your A is always in front of your x. So there's my x. The coefficient in front is a 4. Your B is always in front of the y. So the coefficient there is a negative 2. And your constant is always the one that's on the other side, which is a negative 5. So with that being said there, that is exactly how you put it in standard form. Now, one more problem, it's going to be a lot quicker than you think. Now, can I put this in standard form? Well, let's start off with deciding whether if this is even a linear equation. Now, is this a linear equation? No, because you're dividing by a variable. Whenever you're dividing by a variable, that's a variable by the way, whenever you're dividing by a variable, you are not going to get a graph that's a linear equation. That means that this is not even a linear equation. There's no way you can put it in standard form. You just have to tell me no and tell me why, and you can move on. So you might ask, why in the world are we spending all this time figuring out this form? The reason it is because it is super, super easy to graph. If I give you these equations, 1, 2, and 3, it is super easy to graph if you have them in standard form. Now, Before that, let's cover something really quick. Since 2 points determine a line, I could draw 2 points anywhere and draw a line through them. One way to graph a linear equation or a function is to find the points at which the graph intersects the x-axis, the x-intercept, and the y-intercept. Now, let's keep this in mind. And if I'm finding the x-intercept, and here's my ordered pair, what is true about all x-intercepts? Now, here's my x-axis. Here is my x-axis highlighted. What is my y always going to equal when I have a coordinate point on the line? It is always going to equal 0. So that means that I know, for instance, when I'm finding the x-intercept, I know that my y is always going to always be 0. Now, what happens when I'm trying to find my y-intercept? What does my x always equal? Well, your x is always going to be 0. Now, depending where your point is, it's going to depend on what your y is, but no matter what, that x is always going to be 0. So what does that have to do with graphing? The main reason is because if I give you something in standard form, it is super easy to find 2 points, and particularly the x and y intercept. All you need to do is plug in a 0 in for x and solve for y. Whenever you do that, you're finding the x-intercept. When you put a 0 in for y and solve for the x, you're getting the x-intercept. Now watch how easy this is. I'm going to change colors so that way you can see it a little bit better. I am going to start off with finding my y-intercept. I'm going to plug in a 0 in for x and solve for y. 3 times x, which is 0, minus 4y is equal to 12. Notice that these cancel out. 3 times anything is 0. I'm left with negative 4y is equal to 12. To solve for y, I'm going to divide it by negative 4 on both sides. I end up with y is equal to a negative 3. Super easy to solve once you're in standard form. So let's go on and find our y-intercept. X-intercept. In order to find the x-intercept, you have to put a 0 in for the y and then solve for x. So here is my y. I'm going to plug in a 0 just by writing over it. I can see that negative 4 times 0 is 0. You end up with 3x is equal to 12. Divide by 3 on both sides, x is equal to 4. Super easy to find your x and y intercepts. And now you can graph these points and graph them really easy. 0, negative 3 is right over here. 4 and 0 is somewhere over here. And then that is your line. All right, so very next one, so that way you can see it. As soon as you see something in standard form, you guys should automatically make your table, put a 0 in for x, solve for y, 0 in for y, and solve for x, and of course do it separately. Now, whenever you're doing this work, it's kind of easy just to, this is what my teacher told me when I was taking this class. When you're finding the y-intercept, you're going to plug in a 0 in for the x. Anything times 0 is 0, so what you can do is scratch it out, put your finger over it, do whatever you have to, and just solve for the y. Clearly there, all we have to do is divide by 5. We end up with y is equal to 2. So these problems become super quick if you know that strategy. All right, so let's do the next one. We're finding the x-intercept. So I'm going to plug in a 0 in for y. These are going to cancel out, and notice I'm left with 2x is equal to 10. Dividing by 2 on both sides, x is equal to 5. So in order to graph these, 0 and 2 is, let's see, right over there, and then 5 and 0, 1, 2, 3, 4, 5. As best as I can, it's going to be here. All right, so make sure that when you guys are solving these problems, you are writing down your table, because that's how I'm going to know that you guys are actually finding your x and y intercepts first. All right, so number 3 seems a little challenging with all the fractions, but remember, in order to be in standard form, just get rid of the fractions to start off with. Notice that I have a 2 there, so I'm going to multiply everything by 2. These cancel out. You're left with x is equal to, these 2's cancel out, so you're left with a y is equal to 8. Super easy, right? It's pretty much, not pretty much, it is in standard form. Put a 0 for the x, solve for y. Put in a 0 for the y, and solve for x. Putting a 0 in for the x, these are going to cancel out. You're left with y is equal to 8. Putting a 0 in for the y, you solve for x, and x is equal to 8. Hopefully I said that one right in the other one. So that is pretty much why we are learning standard form, because notice that once you have an equation in standard form, it is super easy to find the x and y intercept. And once you have your x and y intercept, it's super easy to graph them, which I forgot to do here. 1, 2, 3, 4, 5, 6, 7, 8, somewhere over there. 1, 2, 3, 4, 5, 6, 7, 8, somewhere over there. Again, what I'm looking for is this guy. If you did that right, I know that you did the top right. All right, so keep in mind that whenever you're graphing, there's going to be problems I tell you to put in standard form first, and you have to put them in standard form first, and then you have to do all this work. But there's also going to be problems that I tell you, just graph it, find the x and y intercept. Now, if you use this concept of plugging in a 0 for the x, solving for y, 0 for the y, and solving for x, you could bypass making it into standard form if you want. For instance, let's look at this first one. They tell me the directions to find the x and y intercept. So I'm going to make this little chart here so that way I can kind of visually see it. Plug a 0 in for my x and solve for y, 0 for y and solve for x. And I'm just going to do with this equation. I'm not really worried about it being a standard form because the directions are not telling me to. So I'm going to plug in a 0 in for x first. 2 times 0 plus 10 is equal to 5y. These cancel out. Notice I'm left with 10 is equal to 5y. Divide by 5 on both sides. That means that 2 is equal to y. All right, so almost there. Now I just need to find my y-intercept. So in order to find my y-intercept, what I'm going to do is I'm going to plug in a 0 in for the y. Now I'm going to do that over here. 2x plus 10 is equal to 5 times y. Notice that 5 times 0, which is my y, cancels out. You're left with 2x plus 10 is equal to 0. And then it just becomes a very algebra 1 problem. 2x is equal to a negative 10. Divide by 2, divide by 2. X is equal to a negative 5. So there's my x and y intercept. 0 and 2 would be my y-intercept. And then my x-intercept would be negative 5 and 0. All right, very next one, just to give you one more example. Just to reiterate, notice that this is not asking me to put it in standard form. It's asking me to find the x and y intercept. So I technically don't have to put it in standard before I do that. So let's just go ahead and solve the problem. 0 for x, solve for y. 0 for y, solve the x to find my x and y intercepts. I'm going to start with y-intercepts. I'm going to plug in the 0 in for x. Negative 3y plus 6 times 0 plus 12 is equal to 0. Remember, 6 times 0 is 0. You're left with negative 3y plus 12 is equal to 0. Now, in order to solve for that, I'm going to minus 12 on both sides. Negative 3y is equal to a negative 12. Dividing by negative 3, y is equal to a positive 4. All right, one more to find. I'm going to find my x-intercept. I'm going to plug in a 0 in for the y. So, negative, let me do it a little nicer color so that way you can see it. Negative 3 times y, which is 0, plus 6x plus 12 is equal to 0. Negative 3 times 0 is 0. You're left with 6x plus 12 is equal to 0. Minusing 12 on both sides, 6x is equal to a negative 12. Divide by 6 on both sides. Finally, x is equal to a negative 2. So here is a negative 2. And that is how you pretty much find the x and y intercepts of linear equations in order to graph them. That is how you find out whether you have a linear equation.